Yeah, thank you, Olaf. So, as some of you, most of you know, I'm Adam Attaheri, and one of my roles here at the CBU is providing support for the online testing. Sorry, I'm not able to be there in person, but it's probably quite apt that a talk about online testing is being done remotely. So, I know that there are numerous people in the crowd with detailed experience of online testing. However, since my talk last year, I know we've had a lot of new starters, so please excuse any of the elements of the talk that cover things you've already know. I'm going to briefly cover what online methods do we support at the CBU, the steps required to run an online experiment at the CBU, resources and support, and some common issues and solutions that I've encountered with supporting people. So firstly, what do we have? Well, we have various softwares and platforms for online testing. The main two seem to be JTOS and Gorilla. Now, I'll go into these in more detail over the next few slides, but as well as these main two, there are people in the center using other code libraries and platforms, but as I said, the majority of work is on JTOS, incorporating JS and JavaScript, as well as some people using Gorilla. As well as the behavioral testing, the university also has a Qualtrics license, which any CBU user can access, which allows you to send out detailed questionnaires online. And finally, I'll briefly mention REDCap here, as this is something I'm currently spending a lot of my time working with. I'm currently uploading all the CamCam data onto a REDCap database, with the end goal of making it easily accessible and queryable data set that is accessible online and remotely. So if anybody has any interest in accessing any of the CamCam data online or even putting some of their own results up there in their own form, please let me know. That's something else you can email me about. So I'll start with JTOS. JTOS stands for Just Another Tool for Online Studies. It's an open source software designed for hosting and managing online experiments. As I mentioned previously, JTOS is probably the most commonly used platform at the CBU. It allows you to compile various bits of code and then use JTOS to host it and send out your links to the participants online. The most common, even though it's flexible, the most common setup would be some sort of combination of HTML, CSS, and JavaScript code. And the JavaScript is often implemented via a toolbox of commands, with JSPsych probably being the most popular. For people who aren't aware of what these stand for, the HTML is used to create the actual content of the page, such as the written text. The CSS is responsible for the design or style of the website, and then the JavaScript is the part of the code that's used for building interactive and dynamic content on the websites. A little brief thing about JSPsych. It's an open source JavaScript library specifically designed for creating behavioral experiments in web browser. However, JTOS is also very flexible. You don't have to use JSPsych. For example, some people in the CBU are incorporating things like Phaser or Google Cloud text-to-speech things into their JTOS code. One nice thing about JTOS, it's sort of in keeping with the MRC mission of it being free and open source, and it also easy to link it to online participant pools. Most commonly, people these days use Prolific for recruiting their participants. Now, I'll cover most of the pros and cons of JTOS on a later slide, but one of the main advantages of JTOS is it's the one that I've got most experience supporting. So I put a little animation in there. Me and you will work our JTOS problems out together. So in practical terms, if you want to use JTOS, you just need to download two elements. Firstly, you'll need to download some sort of code editor to create and modify your JavaScript. For example, I use Sublime Editor to edit my code. And after this, you can run your code on a local installation of JTOS on your PC to see if it's working and play with it before you finally upload it to the CBU JTOS server. And then if you look on the bottom right-hand side here, you can then access your data and your experiments through a web platform that looks like this. So now the other option that we have is Gorilla. Gorilla is another cloud-based platform for creating, hosting, and running online behavioral experiments, and surveys are also possible in Gorilla. And the CBU also has a site-wide license for Gorilla. Now, the main difference is that Gorilla operates a more intuitive, user-friendly interface, and it's probably better for people with less programming experience. Tasks can be built by dragging and dropping components like surveys, different tests, and stimuli, and it has a very easy graphical user interface for this drag and drop. Therefore, it's very easy to make simple, aesthetically pleasing experiments. It is based around ease of use, and it has nice features such as you can easily set up a trial order in a CSV file, which you could upload, and then that's immediately integrated into the drag and drop screen. So there's quite a simple way of making experiments. However, there is some capacity for adding in more complex JavaScript or HTML, but you are a bit limited with the custom things that you can add into Gorilla, even though it is possible. And I did this here just to give you an idea of what that looks like. On the right-hand side, you'll see this drag and drop sort of little modules that you can put together into an experiment. And then if you clicked on one of those, you'll get the image on the left-hand side where you can just upload your images or stimuli or whatever. So as I say, it's very easy to use if that's something you're interested in. Whilst I've briefly touched on the pros and cons in the previous slide, the most important thing for you in deciding what best option for you is the pros and cons. So I'll start with JTOS. The pros are it is completely free to use and highly customizable, and how also is JSPsych is very easy to implement in there as well. So there are some toolboxes ready for your experiment. JTOS allows sort of fine-grained control over the experimental design through the JavaScript and, say, JSPsych's extensive library of plugins and extensions. And it's very suitable for implementing sort of highly specific or novel paradigms. The experiments are hosted on the CBU server, so we've got complete control over the data storage and access, which is very useful. And it offers flexibility in defining how the data is saved and exported. So you can save your results as you go along, or at the end of the experiment. It's quite flexible in your data collection. And if you do have some coding experience, JSOS is far more flexible in what you can achieve in terms of complexity. The cons are it does require some programming skill, especially some sort of familiarity with JavaScript or HTML and CSS would be quite useful. And some familiarity with JSPsych, even if you're going to use the toolboxes. However, important to remember, there is a wealth of experiments already at the CBU that you can easily access and modify, so don't worry about that too much. It does lack a sort of graphical interface, which does make it less accessible for researchers without a technical background. And whilst there is some documentation and community support, it doesn't have a dedicated customer service like Gorilla, so there's no one necessary to email. However, as I said before, I'm here to sort of fill that role. Over to Gorilla now. The pros, as I say, it offers an intuitive drag and drop interface and minimal programming knowledge is required. It's got a lot of pre-designed experimental templates and tools for surveys, cognitive tasks, and the built-in task library can simplify your experiments creation. It also has easy integration with participant platforms like Prolific. It automatically collects and organizes the data into a sort of more recognizable downloadable format like a CSV. Whereas one of the quirks of JTOS is that the default option for downloading your results is a JSON text file, which can be a bit fiddly if you've not encountered one of those before. Gorilla does have very responsive customer support, as well as lots of documented tutorials online. And basically, it's very good for quickly prototyping and deploying standardized experiments without any need for extensive coding. There are cons, though. Gorilla is a commercial platform with a subscription model, which, although as I say, we do have a license here at the CBU, that might be something you want to factor in if you have a long-term use for the experiment, if you want to take this experiment somewhere else afterwards. There's limited customization, so while it's quite powerful for standard tasks, it lacks the flexibility for complex custom behaviors or sort of niche experiment setups, if that's something you're interested in. And the experiments are tied to Gorilla's ecosystem, so it makes migration to other platforms quite challenging if you want to move your experiment to a different platform in the future. So I've already briefly summarized most of these advantages of each feature of each platform, but I'd say the main decision comes down to your level of programming experience and the complexity of the experiment you wish to run. So where do you start? So reading the intranet at the CBU is probably your first port of call. There are numerous dedicated pages on the CBU intranet providing lots of information. Or please email me and I'll be more than happy to provide any assistance. One thing that I might be able to do is direct you to a CBU researcher that's already ran the experiment that you want to run, or at least something very similar, and that could be a good template for you to start from. If you decide to use JTOS, you can download a local installation onto your PC so you can have a play around with designing the experiment before you move on to putting it up on the server. So that's your starting point. Once you have your idea for your experiment, the next stage is will most likely be contacting the Web Experiment Management Committee, i.e. the WebMC. The WebMC is a committee of CBU scientists, admin and IT staff who are involved in online testing, who will advise on things like technology, methodology and ethics, and then approve or not approve your experiment. Now you can contact the WebMC informally. However, the next official steps in getting your approval is sort of dependent on the cost of your experiment. So if it's under 100 quid, you're just looking for some pilot funds, it might be possible to run the pilot without a WebMC while having to complete an application form. However, if it's more than £100, you'll need to complete an application form. And this form covers things like ethics, study design, and technical considerations. And the approval of this from the committee is required before you conduct your study. If the total cost of your study is over £1,000 in MRC funds, you'll need to present your proposal at a PPM or a project presentation meeting before submitting the application. These meetings give other unit members the chance to provide feedback about your proposal and learn about your methods. It's especially important for researchers who are new to web-based experiments. These are 30-minute slots with about 10 to 15 minutes for the presentation and the rest for questions and discussion. And any questions, comments, feedbacks that are raised during the PPM should be re-included in your application before you submit it to the committee. For new starters who haven't seen or done a PPM before, it's nothing to fear. In fact, I sort of think the collaborative nature of this feedback is one of the things that makes the CBU such a great place to work. It's quite a really useful endeavour, and it always improves the quality of the applications we see coming through to the committee. If the total cost of your study is less than £1,000 in MRC funds, then you are not required to do a PPM before submitting, but you do need to do the application still so that you can get your approval. And one final thing to mention is that the committee can be quite flexible in projects that are funded by external grants, but we still advise getting advice from the other CBU members before collecting your data. So what resources are available to help you getting going? Well, firstly, as I said, many of the experiments have already run at the CBU, and my long-term goal is to set up a web repository where you can easily access the code in these experiments to download them immediately. But in the meantime, whilst that's work in progress, please feel free to email me. And if the experiment you want to run already exists, I can either share it with you or connect you to the researcher that created it. I talk about the CamCam project here because this has lots of ready-to-use JTOS versions of tasks like the Cattell, spot the word, reaction time, digit-symbol substitution, word meaning tasks, many more. And the nice thing about this is because the CamCam's got a lot of data already collected on these experiments, we can not only provide the full built paradigms, but also you could have some norm data if you wanted to compare to. JTOS and JS site websites also offer many free-to-use ready-made experiments that work seamlessly on our JTOS server, and I've listed some examples there. And finally, if you're willing to wait until February, I'll be hosting a in-person workshop as part of the neuroimaging lecture series at the CBU. And this should be a great opportunity to discuss or develop any experiment you're working on. The workshop is free and open to all researchers at Cambridge, and it's there on February the 25th at 2. So in addition to online tutorials, there's several resources. There's the Be Online conference, which is a great resource listing the latest advances in online testing, and a lot of these materials are available free online. There are a couple of papers sharing tips for improving online data collection. I've highlighted Jenny Rod's paper here. It's useful guidance on collecting high quality data. And finally, don't underestimate the sort of value, as I said, of talking to CBU colleagues, because many people have run experiments online and are happy to share their codes and insights. I won't read this whole slide, but I just wanted to briefly highlight um, many, how much has happened at the CBU over the last year. And this was just a quick look through my emails, and you can see there's different platforms, different methods, different participant groups using both JTOS and Gorilla. So there is a lot of wealth of knowledge in the department. And this is my last slide. Just sort of in the last minute, I wanted to highlight some of a couple of the common issues and concerns that researchers have emailed me about over the past year. Some people have encountered issues uploading their experiment to our server, and it just thought it's nice to highlight that the maximum experiment size has to be 2 gig, and that should be more than sufficient for most studies, but keep in mind when designing your experiment, that's how much you've got to work with. Retaining participants seems to be a big issue, and while the minimum pay on Prolific is £6 an hour, evidence suggests that paying at least £9 an hour does improve the quality of your data collected and your retention rate. So that's something the committee is considering for future applications. And finally, many people worry about the timing precision of online experiments. And I just want to guide you to a helpful resource is Alex Irvin's paper, which reviews the timing performance across platforms and operating systems and web browsers. I won't dwell on this for too long because I covered it in my talk last year, and you can access that talk on the CBU website. But basically, if your experiment doesn't rely on reaction times below 100 milliseconds, there's very little to worry about. And even if you do care about reaction times before 100 milliseconds, while the accuracy might not be perfect, there might be a lag. Precision across trials and participants is generally within 10 to 15 milliseconds. So there are the quality of the reaction time data is still getting a lot better. And yeah, thank you for listening. That'll be the end of the show.